We are on day 42, which is on 14th of June 2025. So what is it we are looking is like actually we are looking on OT protocols. So the protocols what we have covered until now is Modbus, then followed by DNP3. Yesterday we discussed on Profinet. So yesterday we gave a assignment that what will be the cyber security concerns on this, which we'll discuss not today because I want to complete the remaining three protocols which are there. Then I want to discuss commonly. Just keep the notes with you what you prepared. Okay. Today we are going to see a protocol which is completely new to this industry. Like we call the protocol with a number, which is called IEC. Okay. Protocol what we are going to discuss today is IEC 61850. This is a protocol. Okay. This protocol is especially designed for an industry or a sector of electrical power distributions. Wherever we have an electrical power distribution, high power transmission rates, and wherever we are transmitting the power, in that industries, this protocol is very frequently used. Okay. What is this? First, we'll see what is this IEC stands for. IEC itself stands for International Electro Technical Commission. Okay. This is a body, an open source body, which maintains the protocols, communication standards, which are generally used in the power transmissions, means power grids. Okay. So now these people have come with a protocol. This protocol is called IEC 61850. This body especially designed this protocol, okay, for the communication between IEDs. Whenever you need to communication between my IEDs. What is IED? An intelligent electronic devices. We call this in a power transmission. We use this device for how you're using PLC, RTU, sensors, everything. In power transmissions, in a power grid transmissions, we use this device. This device are called intelligent electronic devices. Okay. For example, protection relays. What happens when a heavy power is transmitting? Okay. We will today discuss on a common example. There is a current wire, there is a power transmitting through a wire on for a kilometers for one substation to next substation. In between, there are some trees. Okay. And this current cables are very close to this big trees. So unfortunately, because of a huge wind, a big branch has fallen on the wires or it has tilted down where the two electrical power transmission cables got short circuited each other. Okay, this is a case. What happens? Heavy power starts flowing. There is a surge in the current. Means all of a sudden, until now, there is a 230 volt power is traveling. When this voltage of power of amperes is traveling, when these two wires connected each other, short circuited each other, the current all of a sudden increased to the power capacity watts of 240, 260, 300 watts. So an example I'm taking. Now what happens? There will be an intelligent electronic device in the transformers. So when the current increased all of a sudden, okay, the transformer will get burst or it gets spoiled. So to safeguard the transformer, they'll place a protection relay. They'll use a relay called circuit breaker, a concept called circuit breaker, which is called protection relay. So whenever this the current all of a sudden gets surges, there will be an instruction coming from the intelligent device to this IED, intelligent devices that open the relay. So automatically they'll open the relay and the power will not flow from this transformer to that transformer and the transformers will get safe. There is a safe mode. So here the decision is taken and safeguarded by IED, which is called electronic devices, intelligent electronic devices. Now, when the substation to substation, there will be one IED in one substation. For example, I have a substation. You know what is substation? The power transmission centers. Okay. I have a substation. I have another substation like this. When the power is transmitting from here to here, the communication between these two transmissions will be taken by IEC 61850. Why? Because in this substation, there will be one device. This will be one device. The pink color box is what I'm using here. These devices, I'm calling them as IEDs, intelligent electronic devices. Okay. These are called intelligent electronic devices. 1 minute, guys, excuse me. So now the communication between this pink box and this pink box will be taking place with a protocol called IEC 61850. So what is this protocol? How is this protocol frame structure is there? What are the different parameters we understand at this? We'll see it today. Am I clear, right? So if anybody asks in a single statement, can you define the protocol IEC 61850? I will give a single statement that it is a communication protocol, okay, used between IEDs. What is IEDs? Intelligent electronic devices at electrical substations. Okay, electrical substations. Any doubts, please? So this is majorly used in the electrical power transmission concept in the industry of electrical grid power transmission industry sector. Okay, this is a protocol. Now, when I break down this protocol into different areas, okay, let me come back. Okay, first, what are the components in this model? What are the components? Means the parameters used in this protocol model. In this protocol. What protocol we are talking? IEC. What is the protocol number?
61850.
Very 61850. Remember this, it's important because IEC has differently. I want to discuss majorly on this component. So what are the components used? The terminologies are very common. The first one is, we'll call it as, they will use this, the component called physical device. Okay. The second one they call it as logical device. Okay. And logical node. They represent, actually, when you see any Google or anywhere, you will see this LD. This is called logical node, which is called LN. Okay. This is called data object. This is DO. And they use one more called data attribute. This is DA. DA. Okay. These are the, excuse me, done. Okay. What are these individually we'll discuss. First, what I'll do, I'll give a single statement for each and every component. Now I will take a real-time example and I will explain how each one is related in that example. Okay. First, I'm giving the single sentences because to understand. Okay. You may not have a clear idea. When I give an example, you'll get it. When I talk about a physical device, okay, a single statement, what I want to give is like, it's a hardware which can be seen. You can see this, okay, and touched. Like you can see them, you can touch them, anything. Okay, like a release. I'll talk about example. Take an example here. Okay, I'll take these examples all in a real-time example. We call this as protection release. Protection relay. How they look this? Okay, let me show you this. We call them in industry as feeder relays. Feeder relay in substation. this. These are called feeder relays. Okay, the devices will be like this in the substations, which are physical devices. This will be programmed by a microprocessor, electronic microprocessor inside it, and the programming will be written very clearly, which will take the things. Okay, this is a hardware. What is it? I have seen this literally when we are doing some survey. These are the hardware devices in the industry which send signals to the circuit breaker. There will be a circuit breaker. I'll show you circuit breaker also. Okay. Circuit breaker. Power explanation. Like this. These are circuit breakers, relays. Now these circuit breakers will get the signals from what is it, feeder relays. Okay, I'll say the concept. I'm coming back. Okay, just to give an idea how the industry looks, you have to imagine what is happening when I'm talking. This will help you. Okay, these are circuit breakers. You will see at the transformers. Okay, let me come to my note. So now all these physical devices which you are able to see or if you are able to touch, this will come under physical device concept. Okay. The second one, which I am calling as logic device, logical device, and they denote it as LD. What is a single term? The example, the statement, this is this. Okay. It is a virtual grouping number. What is grouping of functions? It's a virtual grouping of functions. What is functions? I'll give an example. Okay. Which are inside the physical device. See the concept. Okay. This will be always this physical device. Means there'll be some functions. What is a function? One logic device I'll give you. Okay. I took the example, right? Protection relay. For example, this is my protection relay. So it is a big hardware like this. In this hardware, you will have two functions. This relay will perform two functions. Function 1. We call this function 1 as PLD. PLD. What is PLD? Protection logic device. Okay. This function is called protection logic device. Okay. There is another function we'll call function 2. Where in this relay inside, this is called as what we call measurement logic device, MLD. Measurement logic, MLD. What is this MLD? This stands for measurement. It's a logic, it's a software code, logic device. Inside this protection, there these two functions are there. What is these two functions? For example, when I'm talking about PLD, that is protection logic delay, what it does, it contains a functions related the protection the feeder, means to safeguard this relay, what is the maximum current it should allow, it should not allow. That logic will be written in PLD. Okay. What is an MLD? This MLD will measure the quantities, means this is a measurement logic. It will measure the current continuously. What is the current flowing? What is the current flowing? What is the current flowing? When the current flowing increases to the limit, when it crosses the limit, it will immediately trigger function 1, that is PLD. Protect the device, switch off the device or break up the device. So these functions which will support my physical device, these two functions which I am writing here, okay, these are called LDs. What is LD?
Logic device.
Logical device. This is PD. Means always a logic device will be inside the PD. Is the two things clear? I'll give an example to you. You will understand very clearly. Now only understand single statements. What is PD? Physical device which you are able to see and touch. What is logic device? It is a function inside your PD which allows or safeguards your PD. Am I clear?
Yes.
Done. So you got a concept. What is PD? Physical device. Then what is PD? Inside PD, what is inside PD? That is, sorry.
Function.
Logic device. Okay. Now I'm talking inside logic device, there is a concept called logic node. Means inside the function, this is a function. Okay. This is a function. How this function will be executed? Using logic node. What is logic node? It's a specific electrical function without the logic, within the logic device. Means it is a, I'm just giving a single statement. Specific electrical, very important. You have to use electrical function within the LD, that is logic device. Example, okay? I'm giving one example. The example for this is, I'm giving for logic node. One example is, we use a logic node called PTOC. There's a common, very commonly used. What is PTOC? Protection time over current. P stands for protection time over current. Okay. What it does, this is a node, okay, which monitors the current and decides if this exceeds the limit, okay, then it will send a thing. For example, I told you one branch fall on the wires, then increase in current. Who will detect it first? It will detect by PTOC. Then this will specific function, which what is it is increasing. This PTOC is only measuring one parameter. What is the parameter?
Flow of current.
No. Flow of over current.
Over current.
It is only measuring a protocol called overcurrent. Now, when a overcurrent comes, this logic node will inform the logic device that, bro, the power is there. Okay. So now see the example. I have a PD, means I have a hardware. Now, your concept is, team, this hardware should be always safe. How I'll be safe? Now, this will be getting a feed inside with the help of a function. What are the functions? You have two functions, okay, which are called, these are called LDs, logical devices. So I have a functions. What are two functions I have? One is MLD and one is, what is it? PLD. Now what happened? Now this MLD needs an input. This MLD will also get an input from another device, which is called logic node, LN. That is called LN. When there is a current increase, this will be detected by a function, particular function, which is called PTOC. When the PTOC sends a signals to MLD, this MLD, first thing, when the current increases, the PTOC will detect and immediately inform MLD. It will give a, this is a measurement value. Then this measurement value will indicate my LD that please switch off the hardware. Then the switch, it will give an information to hardware to off. So automatically my hardware will be safe. So now if you see the interlink, your target is PD, but PD is dependent on LD. LD is dependent on LN. Am I clear, everybody? Yes.
Yes.
Now this LN will have a language. That language is called DO, which is called data object. What is data object? It is a piece of information that logical node will understand. Okay. Now logical node will not understand every language. This logical node will understand only particular language, that is called data object. For example, whenever there is a PTOC, what is PTOC full form? PTOC, protection time over current. Whenever there is a overcurrent, okay, this PTOC will have an object called, let me give one more color. Which color will you? I'm using pink. No? I'll use red. No, not red. Better green. Okay. This will, the PTOC will use an object called OP. OP. This OP is called operating object. And it will also use an object called POS. POS stands for, what is this? I forgot this POS full form. It operate and position. The POS stands for position, I think. Position. For example, what happened? Operator will change. What is it? It's called change state. Okay. Now, for example, let me take, the color is not visible to me. Let me take this. I have a data object called operator. This object is two things. It is saying the current is high or low. Now the current is high. For example, the operator will change. Operator changes the state from low to low, high, normal. Until now it is normal. All of a sudden the current increased. Immediately the data will change to this mode. Which mode? High. When the op changes to mode, it will send a signal called position. What is this position? The circuit breaker. The circuit breaker will be like this. It is a switch. It is generally a switch like this. Like this. It will connect. Now, if the switch I arrange it like this, is the switch connected or open? The pink color,
Open.
Not
it
connected.
is open. Means the circuit is open. Now the connection, see me. Now the connection is closed. Now the position has two states: open, close. Now what happened? Whenever the current is high, the data object will come to high, position will come to close. Then this POS will be given to my PTOC by it is a high current close. Now PTOC will understand this language. Oh, it is close instruction. Immediately instruct my MLD. Then MLD will react to this. Means what is happening? Your PLD, sorry, your physical device is dependent on a language which is called logic device. Your logic device is always dependent on a logic node. Your logic node is dependent on a data object, and the data object is dependent on a data attribute. Okay. Now see the example. What is this example? There is a transformer, there is another transformer, and there is a current flowing. Okay. Unfortunately, there is some abnormal activity happened on this transmission, and the current which is flowing here has increased all of a sudden. Very high current is flowing. This is a scenario. When the scenario say the data object which I'm seeing, where is this colors? Why this is coming so big? Now this first thing will start is data attributes. When this abnormal activity comes, the data attributes will say it's a true state, means something is happening. It's an abnormal activity. When it is true, the measurement value will transfer here, and data object will have two objects. What is the two objects? Operation and position. The operation will change to high and position will change to open. This language will be sent to my LN. So my LN, which is logic node, will indicate my PTOC. Oh, the PTOC is coming, it is open. Now the PTOC signal will be given to my logic device. And my logic device, which is having my MLD, it will understand and it will instruct my PLD to open the device. Now the physical device will open the circuit and it is safe. Am I clear with the example?
What's DA?
DA is data attribute.
Okay.
Data attribute. Okay, this language you never implement, but you should know this protocol, because when they are creating a baseline, they will say my data attribute is true. What is data attribute? Means the condition, what is the abnormal activity happening is yes or no. It will be decided by data attribute. Once the data attribute is true, then the data object will be changing. What is the data object? Data object is not constant. It will always change. Now, data objects are two types: operation and position. The operation, it is until now it is normal. When it is true, it changes to high. Let me give a color. It changes to high. When it changes to high, the position until now it is closed, means the current is flowing. Now it is asking to open. This data will be sent to my node. The node inside my logic device. The node is a indicator. That is just a function inside. It will indicate. It will trigger a function. The function which is triggering is called PTOC. What is a PTOC trigger? PTOC stands for protection time over current. Now this function will trigger my logic device, which is a function. There are two functions. Which functions? MLD, which is my measurement logic device, and protection logic device. This measurement protection device will show high. Immediately my protection logic device will please open the circuit. Now the open information will go to my physical device. My physical device will immediately open the circuit, and this large increase in current will not flow into my transformer, and the transformer will be safe. Am I clear?
Hmm.
Am I clear or no?
Yes.
No, what are the components? This is a language which is especially used in IEC 618550. Okay, this is a language which is especially used. So what are these? These are called components of 61. What is it? Physical device, logical device, a logical node. Logical node will be answered by data object. Data object will be triggered by data attribute. Am I clear with this concept?
Yes.
Yes. Now, in this protocol, which is a protocol that is a IEC 61850, the communication happens in two types. That is called communication services. They'll ask this. This is important. The communication services which takes place in two types. One is called goose service. Another is called MMS service. MMS service. Goose service stands for, see, these are all depending on the sectors. You may feel it's tough when you talk this language in the interviews. You remember, they will really feel you have an experience. That is what I'm going a bit deep inside and discussing. Okay. Now, the goose service stands for generic object oriented substation event. This is my thing. Generic object oriented substation event. This is especially a communication which is designed to identify, or when an event happens, this will be used. Goose, a very famous word in our electrical industry, the power transmission industry. I'm sorry, goose. MMS stands for, okay, that is very cool. Manufacturing message specification. Manufacturing message specification. Okay, what is this two difference thing? Kiran, what is this two communication? Goose and MMS. Okay, goose. My goose, especially, I will use it for high speed peer-to-peer transmission. High speed peer-to-peer communication. Good example. I'll give an example. Give me a minute. I wrote an example. I got an example today. MMS, which stands, it's a client server communication. Please understand this. Now, there is a power transmission relay, and this has a relay 1. After 2 kilometers, another relay, another relay, another relay, another relay, and this is my another power station. Now, when the power is transmitting, it's transmitting to all the relays. It is some 200 kilometers, 300 kilometers transmission. Now, what happened? This relay, okay, found an abnormal activity, means something is danger. Means there is abnormal activity. Immediately, this will trigger an event. What is event, guys? Means what happened, if anything abnormal danger happening or anything which should not happen, it is detected by this relay. Then immediately it will observe it as an event. Did you see any word called event until now in the discussion today?
No. No.
Can you see this? What is this?
Goose. Okay.
What is goose? Generic object oriented substation event. Can you see this event?
Yeah.
This is event. Means what is event? Any abnormal activity happening. Now this relay have to immediately communicate to all the relays by there is a event, there is event, there is abnormal. All the relays should immediately off, 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 off. Now who is talking? This is my master. These are all my slaves. Is the master talking to the slave? No. The peer means my peer means classmates, friend, means the same community people. If there is a teacher, okay, for example, in the engineering college we talk, when you do our engineering, they will say peer-to-peer learning. What is peer-to-peer learning? And a senior will come and teach the junior. A student teaching a student. A teacher will not teach the student. Peer-to-peer education means a student who has the knowledge will come and teach the next student. This is called peer-to-peer communication. So now this is one relay, this is another relay, means a relay talking to relay is called peer-to-peer. So what is this high-speed peer-to-peer? When a peer want to talk to the next peer, means one device want to talk to the next device immediately in a high speed, it uses goose. Am I clear? Means the problem occurred now. First of all, it will, now I said, okay, I saw a power or a, I am in the 5th floor. You people, let me say, okay. Now we are the class. I am the top. Kiran, who is on the top, he is in the 5th floor. Akila is in 4th floor. Amit is in 3rd floor. Lawrence is in 2nd floor. Oman is in 1st floor. Roop Chandra is in ground floor. Now what happened in the 5th floor? I saw a blast. Some power got blast and the fire is coming high. I am in the top floor. Now I will call Akila and say run. Only run. Run. There is the event run. Amit, Akil, and Amit, Lawrence, Omen, Urupchand, everybody, I called everybody in a call and said, in a WhatsApp, I messaged it, run. Run, that's it. Now, I will call the Akila, then I will call Akila and say, Akila, you know what happened? Today there is a fire accident and the fire is in front of me. You know, the temperature of the fire is 20 degrees centigrade and it may come to you in a span of 5 seconds. So what are you doing? Can I talk like this?
No.
No, I need to say a single language, run. So I am talking, Kiran is talking to Akila, Amit, Lawrence, Oman, and Roopchandra in a peer-to-peer communication. So the communication should be speed or slow?
Speed.
Super speed. This communication is called goose communication. Am I clear?
Yes.
You know what we did? We all ran out of the building. Now the master comes, who is my SCADA, who is my security officer. He is not there in this channel at all. Now there is a security officer. The security officer comes, then from the SCADA mission, he will ping. From the transformer station, he will ping the first Kiran. Kiran, what happened? Can you message me? Then Kiran comes out of the building and say, bro, the power as the current is increased for 20 amperes. Then I saw a fire which is of this time. From this time, the fire started catching up. I will give each and every communication to my master. Now he is my master and I am a slave. That is called client-server communication. So this communication needs a high speed or normal in a form?
Normal.
Normal. This is called MMS. Am I clear, everybody? This type of communication takes place at the things. Okay. So now this protocol, what I am talking, this is my new protocol. That is 61850. What is the protocol used? Especially, just we'll take a roundup of today's class. What is the protocol? Where is the protocol used? In the
Power grids.
electrical power transmission. Okay. Basically, the communication happens between whom? This is a communication between
IEDs.
IED to IED. Okay, next. What are the components used? The components used for this are physical device, logical device, logical node, data object, data attribute. Am I clear? What is the communication happening here? Two communications. What are two communications?
Goose and MMS.
Yes. Am I clear on this?
Yeah.
Done. What is the frame structure? I don't know this frame structure. Actually, I requested one of my engineer who is working in GE Electricals. I want this frame structure because I did not get any frame structure until now. He told he will mail me. Once I get my frame structure, I'll understand, then I'll explain you people. At present, I don't have a frame structure, how the data transfers, what is the header size. I don't know all. How I explain for the remaining three, I don't have an explanation. This is a new protocol. I don't have it. I'm studying it. Once I get this information from my colleague who is working in GE, I'll explain you this. Okay. At present, this is the information I have. Am I clear?
Yeah.
Done. Tomorrow we have two more protocols or one more maximum OPC protocol. I'll try. And if it is done, let me check the protocols. I wrote somewhere today. Where is the protocol? One minute, guys. 1 minute. I wrote somewhere the protocols what are important. One is BACnet and CIP protocol. Tomorrow we'll see these two protocols. I'll try to complete this And once we complete, we are done with the protocol structure. Then I'll go for a PCAP, a Wireshark, and I'll show all this traffic in that. I'll try to get the traffic and show you that how to see this traffic when you are looking at it from a cybersecurity perspective. Each node, how to see a packet, how to filter it, everything we'll see. That will take some 10, 15 classes. Once you understand this, you will develop 1 or 2 use cases. How for a SOC. Then the concept, this is, there ends your SOC concept. What I'm trying to say, what is the class I'm teaching from networking to today is completely to understand my Wireshark tool, means the traffic. Once you are confident in that, then I'll go for the general. How do you do a risk assessment? That is very important. They'll ask in the interview. That next topics will move fast. Risk assessment, it will take 1 or 2 days. How do you perform a risk assessment? What is ICS 62443? This theoretical part. This once you finish, I'll go to practicals. Am I clear?
Yes.
Done, guys. Okay. And as I told you, I'll talk to you tomorrow once I talk to Amit and come back. That's it, guys. Okay. Thank you. Catch you back tomorrow, same time.
Yes.
Okay. Tomorrow, 2 o'clock. I'll try my best. Okay. If not, I may extend the time or not prepone, postpone only the time. I'll see that. I'll update you by today because I have an appointment of, I got a new Emirates ID. I need to go and collect it. That's it. Tomorrow from a friend. I'll finish. I'll check that. I'll update it. Thank you. Thank you, guys.
Thank you.
Thank you.
Thank you.